Welcome to another video of Python for Linguists. Today we're talking about indexing, which is something you can do with both strings and lists. So we're starting to develop methods to actually work with the data we now are able to put into Python. Just a quick recap, language data in Python we've so far encountered in the form of strings. My string, I am a text, but Python does not know that. The in is wrong here. To Python, I'm just a sequence of characters, right? And then we have a word list. I am a list of words. With a full stop here because probably we initially just used white space to split everything apart. And that's kind of the sort of stuff we get. So this is the kind of data we have. And now what do we want with this sort of data? Once again, let me reiterate and emphasize, Python does not understand language. That task is entirely yours. Python has data structures, certain object types, and ways of systematically interacting with these. It's your job to understand what this means in a linguistic sort of sense. Fortunately, strings and lists have a number of things in common. They're both sequences, Python sequences, which is they're ordered arrangements of elements. The ordered is kind of redundant here. Python just calls them sequences, but I like to emphasize the order here. This means position matters, right? Python doesn't understand what a text is, but it does understand that the sequence, the substring a space text comes after I white space am white space in my string above. And it does understand that list, the string list, is the fourth element, the fourth item in my word list above. These things are meaningful to Python, and that sort of gives us something to work with. We can access these individual elements in any ordered sequence, in a list or a string, via their index position. So how do we do that? We've seen a little bit of this already. So we get the item at index position 1 in the string ABCD, for example. Please pause the video and execute this code because there will be a slight learning effect to actually typing it yourself. And once you've typed it, you will have noticed something, right? The first item in any ordered sequence is not the one in index position 1, but it starts at index position 0. So if we access item 1 in ABCD or index 1 in ABCD, we actually get the B back. This is something, just a kind of idiosyncrasy that it takes a few seconds to get your head around to. And as you work with more complex indexing methods, I always have to sort of be aware and play around. I don't always exactly know how to define my indices when it gets to sort of more complex operations. What happens when you try this? You have ABCD and you want to access the fourth index position in here. Again, give it a try. And also this, ABCD, and you access index -1. So if you did this, the first example, index 4, should have thrown an error, something like list index out of, or string index out of range. And the second one will have given you something. And the question is, does it make sense what it gave you, basically? Well, it kind of does. And here's a more structured way of looking at how indexing works. We have a sequence of elements, call them A, B, C, D, E, F here. And if we index from the left, we just do that by positive whole natural numbers. Index 0 is the first element, A. Index 1, second element, B, etc., etc. Up until the fifth element, if we have these 6 here. Written in a more schematic way, this means we always start at 0 and we can go up to the length of our sequence. The S is just here randomly chosen, but basically represents sequence -1. So if we have a sequence of length 6, we can't actually access index position 6 because it doesn't exist. It only goes up to 6 minus 1, which is 5. And then you can also access with indexing from the right? And here you always start at -1, which is the last element in your sequence, and you go all the way down to, so notice that this is not -0 but -1. It's kind of odd. So you always go down to minus the exact length of your sequence to get the first bit. I mean, it'd be highly strange to ever access the first element in your sequence with this negative kind of notation, but that's the logic behind this. So this is basically the basic logic. Typically, I mean, if you're interested in word endings, the last two characters or the last character of every word, you may well be interested in using -1 as the index, but much more often we just use these positive whole number, whole integer values to index, to access an element by its index position. We can also slice, so we don't just have to restrict ourselves to one particular element, but we can get any subsequence that's contained within the original sequence. So if we have the string Mississippi, you can do something like Mississippi and then from element 3, index position 3 to 8. And there's also something, if you exactly consider what that returns when you type that command, that's again something pretty peculiar to consider because the left index here is inclusive. We start at index position 3, so this is the fourth element. You should get S, and then up to, but not including 8. So we get 3, 4, 5, 6, 7. So you should get sissy out of this, but not PPI. Let's just do that really quickly in the shell, just for a change. Go into Python. We have Mississippi. We do from 3 to 8. Right, we get sissy. And index position 8 is actually the first P up here. So we're not including that. The right element in this slicing method is exclusive. Bit of a pain, but again, just something you need to remember. You can also play around with these. Some of these work, maybe all of them work, we'll see. Can you index from position 3 all the way up to 1000? We saw that for accessing a particular index, this would definitely throw an error. What about from 2 to -2? Does it work and does it make sense? What about from -3 up to -1? Try all of these and see if what you get makes sense, whether that is an actual result or an error message. Okay, and if you've done all of these, you just should have found out there's a couple of rules. Trying to access a single index outside the actual range of indices in a sequence throws an error, right? Index error, string or list index out of range. It's a very common problem up until relatively advanced coding that you will encounter. And by relatively advanced, I mean I personally encounter it all the time. Sure, there's much more advanced people for whom this is less of an issue. It's okay though to go outside of the range when you slice, right? It's then Python simply says, okay, I'm at the end of the list and I could keep going, but I can't, so I'll just stop at the end of the list. And also when you have a slice that either begins at the beginning of your original sequence or ends at the ends, you can at the end you can actually leave out any specific index. So you can do Mississippi from index position 3 to and then blank, and that's just going to be Sissippi. All right, starting at the fourth character and then all the way to the end. And the same, you can start blank, that just means starting at the beginning, up until but not including the fourth character, so this would be Ms with one S. And you can do that with a negative number as well. That just sort of the negative number just says up until but not including the PI. So this should give us Mississippi with one P. Let me just make sure that is correct. 2 minus 2. There we go, Mississippi. And so that gives you a lot of flexibility to access individual sequences within a sequence. We've done most of this for strings now, but it works equally fine for lists. And seeing that basically in terms of their inherent logic, lists and strings are very similar is going to be useful early on. It's still a little bit of practice on this. And here you're gonna get to work with lists as well. So first we'll start with a string. We'll call a string or call a variable test and fill it with the string hullabaloo, and then just use slicing to extract the sequence ball from this test. You could obviously just do that by applying slicing directly to hullabaloo, but let's also like kind of continue working with variables, but because ultimately that's what we'll need to be doing. And once you're successful doing that, try your hand at something a lot more tricky, working with lists. So we'll call a list Chomsky that contains the words in the sentence colorless green ideas sleep furiously. And the hardest way to do this would actually be to write the list, right? To start with square brackets, opening quote marks colorless, closing quote marks, comma, opening quote marks green, closing quote marks, etc., etc. You can do this faster if you've been paying attention to the lectures so far. So maybe you can find a shortcut to getting that Chomsky list. And then using slicing methods only and other list operations that we've come across, can you produce the list colorless green sleep furiously? So that's essentially ideas popped out, but we're not going to use a method that pops out an individual element because we haven't encountered that yet. Please use only methods and operations we've actually encountered so far. And then here's something really challenging that I'd be interested in if anybody manages to do that just from Chomsky, from this list of words. Can you produce, by really just using all the operations we've encountered so far and not writing any new variables or anything, can you produce the list furious sleep? Give that a try. If you manage to do that, I think you're on a very good track. And if not, we'll probably talk about it later on. That's it for today. Here's your moderately funny picture for the end of the lecture. Here are the image credits for the image that I used. And if you want to look at the slides in your own time, here's a link, and there's also a QR code that you can scan. Thank you for your attention, and see you for the next video.